Good afternoon once again, and you are welcome to this database modeling with design and design with SQL series. So from the last week, we did an introduction. We looked at what database is. We tried to compare data with information, and we looked at why we would need a database instead of creating a spreadsheet or working with Excel. So today we are continuing with our session. We'll go into the beginning of models. Then in the next session, we'll do that. So models. A model in simple terms, we say is a thing that is used as an example to follow or imitate. So it's more like a representation. You could call it a mock-up, a prototype, or a framework. So I think last week I made the analogy that so when someone wants to put up a building, he creates a plan. That plan is a model. So the builders will follow that model to put up the building. It's the same thing with the database. When you want to design a database, you need to model how your database, you want your data to look like. So that when you start building, when you start the physical design, you have something that is a guideline or a framework that you are working with. That is the same thing we are trying to do over here. But building the model, it needs a lot of collaboration with a lot of stakeholders. So we are trying to look at what role each person will play and that kind of thing. Yeah. So we say it's a set of concepts that is used to describe a database. That is the database model. By describing the database, we look at the structure of the database, the operations for manipulating these structures, and then the constraints that the database should obey. Three main things that we need to look at: the structure, the operations, and the constraints. What do we mean by the structure? I go back to these three terms that I've been talking about: the entity, the attribute, and the relationship. I'll explain this later anyway, but let me just mention. So the entity is more like an individual or an object that you can identify, that you can collect data about. Then the attribute is like the characteristic of that entity. When I give examples, we'll be able to relate with it better. Then we say the operations for manipulating these structures. What operations? We should be able to insert some data. We should be able to delete some data. We should be able to update data that we keep in the database. Then, once we are inserting and deleting and updating, there are certain constraints or limitations that guide the creation of this database. So such are restrictions on the valid data. So we say what kind of data should be stored under what kind of attributes. What should be the length of the data? What kind of values should we accept for particular data or for a particular database? So all of these form what we call the model. So when you are designing the model, you need to take all of these into consideration. The entity, the attribute, how the entities relate with each other, what kind of operations you would perform, the insertion, the deletion, the update, then the restrictions or the constraints on valid data. Now, one of the components of data model is what we call the database schema. I'm trying to explain some of these fundamental concepts because we'll be mentioning them, and it's good to have some idea about it. One of the components of data model we say is the database schema. What is a schema? It is simply a description of the database. How would you describe the database? By identifying the structure, as we mentioned earlier on, by identifying the type of data that goes into it, and the constraints or the limitations. Now, this data schema is represented in a diagram. We call it the schema diagram. So it's just an illustrative display of the database schema. But in this diagram, we don't include everything. It's a simplified diagram. That's why we say most aspects of the database schema. Now, this is an example of a schema diagram. This schema is showing the components or the entities and the attributes of a company database. So in this company, we are able to identify that The company has employees. So there's an entity called employee. It has a department. There's an entity called department. The departments have locations. The company works on projects, or the employees work on some projects. The employees have dependents. According to this company, these are the data that they want to collect. Now, let me just clarify this. There's no straitjacket rule for creating a database. One database could fit for one company, but when you go to another company, it could be a different thing. Some other companies might not use departments. Some might say sections or units. So every database that you create should be relative or should be related to the kind of scenario that you encounter. So here we are saying that this is just a simplified diagram of how the database should look like. In this database, we said the employee should have a first name. We want to shorten it by saying F name. It have a middle initial, the last name, the SSN, the B date, the address, the sex, the salary, and that kind of thing. This gives you an overview of how the database looks like. So this we call the schema diagram, and it contains the description of the database. Now, when you start populating the data, when you start making entries into the database, we call it the state of a database. So it refers to the content of a database at a moment in time. So that is, the first one was just the structure. Now the data comes in and you have something like this. So this is how the data is viewed in the DBMS. Last week we talked about DBMS. I mentioned that that's the software that is used to create and maintain the database, or the database management system. That is DBMS. So it shows like this. So you see employee who has the F name, middle initial, last name, and all of that. And the records are in there. When you're familiar with spreadsheet or Excel, you'll be like, but this is almost the same as what we see in Excel. Yes, because it is arranged or it is structured in rows and columns or in tables here. So this is how the data looks like when the data goes into the database. Okay. Now the main database language, or the main language that is used in the DBMS, is what we call the SQL. Some people call it SQL. Any of them works. The full meaning is structured query language. Structured query language. People call it a programming language, but I don't see it to be programming language because it's easy to learn SQL than maybe PHP or C++ or Java or any of the other programming languages. So this is quite easy because it uses something that is close to natural language. But there are four main sections of this SQL language. I just want to talk briefly about this. This might look a bit technical, but yeah. So the first one on the left is the data definition language, which allows you to create the database. You should be able to alter the data. You can drop. The drop is like deleting the database, or you can truncate, you can rename, you can give comments to it. Then from there, you can use the DML, or what you call the data manipulation language, to select. Select is like retrieving the data that has been stored in the database, or you could insert new data, you could delete the data, you could update the data that is existing in the database. The data control language allows you to either grant access to a particular user or to revoke access. So that's mainly to control the users on what kind of data they can have access to. So this is one of the main advantages of using a database. So for all the data, you could just single out a small section that a particular user can have access to. Or that user can only view a certain section of the data, but then another person could update. So those are the different access that you could grant to the various users. Then we have the rollback and the commit, which is used in the transaction control language. So there are a lot of operations that you could perform When you commit, then you more like commit the operations to take effect. But if you realize, no, this is a mistake I'm doing, you could roll back. So these are some of the operations that could be performed using the structured query language in the database. The database has some kind of architecture or a setup that we normally use. In a single-tier architecture, the database resides on your machine. So for example, this machine or the computer that you are using, if you have access on it and you create a small database with a form that you can make entries, we will call that a single-tier architecture because the data is residing on that same machine. Everything is working on just one machine. We call that the single-tier architecture. In the two-tier architecture, there is the database is sitting on a different laptop or a different computer, and then there are different machines that are connected to it. So for example, the software is installed on the client machines that you see, the client 1, client 2, client 3, but they are all connected to a server, maybe by a network cable or either Wi-Fi or something. When you make any entries on your laptop, it goes into the server. So that creates two layers. So we call it the two-tier. Then the third layer, which comes with the third type, which comes with the 3 layers, we call that the three-tier architecture. So in the three-tier architecture, there's an application, or there's a server. It could be an application server or a web server that sits in between your client machine. The client machine is the machine that you are using. It might not be a computer per se, it could be a mobile device, it could be a tablet or anything. Once it can it can have access to the database, it's fine as a client. But this one passes through a server before it sends the data into the database. And this is typically used in internet applications or online applications. So let's say, for example, I go to Lean Icon Technology website. I'm supposed to register. When I type Lean Icon Technology, it pulls the data from the server and shows it on the client. Then I see the home page. I enter whatever details, that maybe username, password, and all of that. It sends the data back to the server and then goes to store it in the database. That is my registration. The next time I come to Lean Icon and I want to have access, open the web page, I go there, maybe it requires for the username and password again. I enter it. It goes to the server. The server now connects to the database and tries to compare with the initial data that I entered to see if there's a match between the 2 usernames and a match between the 2 passwords. If there's no match, it comes back to tell me that the username or password is incorrect. If there's a match, then it now displays maybe the page that I requested to view. So this is a three-tier architecture, and this is how the whole, most of the internet applications or online applications operate. Yeah. So most of the examples that we'll be looking at will be based on the three-tier architecture. What's my time? 10 minutes more. So now this is where we'll take everything step by step, the database design process. There are 4 major steps that we'll be looking at. So we'll be taking each one during the subsequent sections. We'll start with the requirements gathering, the conceptual design, the logical design, then the physical design. The requirements gathering is something that most of us are used to, where you try to work with the stakeholders to understand what kind of data that they want to store in the database, the scope of the software or the data that they are working with. You can use interviews, use case, user stories, and all of that. William has been talking about some of these user stories and use case things in the design thinking session. So I wouldn't dwell too much on the requirements gathering. For the modeling process, our main focus would be on the conceptual design and the logical design. So in the conceptual design, there we are talking about the entities, the attributes, and the relationships. Now, I mentioned this earlier on. Let me just mention it again. The entities, we said initially that they are the objects or the independent objects that you can collect data about within a particular scenario. So in the company example that we saw, we identified that there was an employee, there was a department. Now the entities that we are talking about here, some could be physical, some could be conceptual. So it all depends on the scope that you are working with. So in the company, you could identify entities like the employee, the department, maybe the various job roles that are existing there, the dependents as we saw, the projects that are being worked on. All of these would be entities. Now, each of these entities would have certain characteristics that would help you know which data you need to collect about. So for the employee, you could talk about the name of the employee, the date of birth, the sex, and maybe the salary that he's taking and that kind of thing. Yeah, so that's we are calling the attributes. Now, entities relate to each other. An employee works in a department, that is some kind of a relationship. And databases that some of these physical relationships should be transformed into the database because that's what makes the database of good quality. An employee could have a dependent. An employee could be working on a particular project. An employee could be could have a particular job role or could be earning some amount or within a salary range. All of these could be represented in the database. When we are done with this conceptual design, we'll move to the logical design, where the entities now becomes tables, the attributes becomes columns, relationships continue to be relationships, there's no breakup anyway. Then we'll now look at certain constraints that come in. There will be keys, there will be referential integrity constraints, entity constraints, and all of that. Those constraints are supposed to make sure that the data that we are putting in our database is of good quality. Then we'll finally look at normalization. After these designs, then we can now go and start creating the database itself in the physical design. Yeah. Okay, so I think there's a question here that I can't see very well. Oh, it's not a question. Good. Yeah, so so from next week, we'll be looking at the requirements gathering briefly, then we'll move on to the conceptual design. Then, oh, okay.
It says, what is normalization?
Oh, normalization is more like one of the ways of ensuring that the data that you are sending into the database is of good quality. So for example, databases, we don't accept redundancy. How do you do that? We need to implement some things that would make sure that there will not be any redundant data. So for example, an employee. Employees would either have their social security number or some staff ID or employee ID. Those are keys or primary keys, as we call it. The database would enforce some of these things to make sure that your data is of good quality. Because without the keys, then your database could accept duplicate data. And that will bring about those redundancies, which is not good for the database. So normalization actually comes in different forms. We start from the first normal form, it goes into the second normal form, a third normal form, a boys code normal form. They are like stages. So you kind of create that kind of thing. So we'll look at that later. But in simple terms, it ensures that your database is of good quality. Yeah. Okay, someone says, is it also like date have to be numbers, name has to be character? Okay, that is more like data type. That is not necessarily normalization. That's more like data type, that kind of data that you are storing there. So for the attributes, when we have the attributes, so like name, date of birth, salary, you could specify. So name should be characters. maybe dates should have a certain format. Salary should be a numeric or in the form of a currency. So you can specify what kind of data should be stored in for whatever attributes. So the database will ensure those things so that you can't enter numbers. No, I mean, you can't enter letters for maybe the salary or something like that. Yeah. Okay. So let me be looking at this.
Hello, Carlos.
Yeah, who am?
Yes, sir. You know, when you were explaining that bit on the conceptual design, the attributes, the entities and stuff, and the relationship, I lost you for a while. Your signal went off just for a while, so I didn't exactly quite catch that. If you don't mind, please just sort of maybe recapping that for just maybe 30 seconds or so.
You mean this place?
Is
it the section you are talking about?
Which section? The conceptual design.
Conceptual design
entities, attributes.
I was saying that, yeah, there are three main things that we look at when we are designing the conceptions. We look at the entities, the attributes, and the relationships. The entities, in using the company database analogy, we could say that the entities are the employees, the departments, the dependents of the employee, the projects that the employee has worked on, the job roles, and all of that. Now, each of these would have attributes. So employee could have the name, the date of sex, blah, blah, blah. The project could have a project number, the name of the project, the location of the project, and all of that. So these would be the attributes because they are giving further clarification to the entity. Then the relationships look at how the entities relate to each other. So we say that the employee works on some project, the employee belongs to a department, the employee has some dependents. We are trying to connect the entities using relationships because all of these will be translated into when we are building the data. Yeah.
Thanks very much.
Okay. Someone says, there's an actual method. There's an actual method one I have not used in ages, but it's quite straightforward. Google normalization, need this and you'll find it. I can't explain it here. Okay, that's in response to what techniques do you use to normalize data. So how do I explain this? Okay, so when you're normalizing the data, there are just some stages. So there are some criteria. It's just a set of criteria that you expect your data to meet. So you can say that your data should have, your record should have a primary key. So if you are creating the schema and you realize that no, there's no primary key, the primary key is just a unique identifier. So if you've created your entity, so for example, for an employee entity, the unique identifier would be the social security number or the staff ID, because no two employees should have the same social security number or a staff ID or a staff number or an employee number. So that is something unique that the database will hold on to say that anybody who tries to enter an existing primary key in the sense of the social security number or something, the database will reject the second entry to say that this is already existing. That's why maybe when you're creating a username on a system, the username is supposed to be unique. So when someone else comes and selects that same username, the database will prompt you that this is already existing. You can't make the same entry. Yeah. So it works in that way. So it's some criteria that has to be met for you to ensure that your database is of good quality. Yeah. Okay. Any further questions or discussion?